Okay, we're back up here. Please have the paper with Pascal's triangle on it. It looks like this. Yes, you want to make sure you write it down correctly. That's true. Okay, Pascal's triangle is a way we can, is some fun patterns for math. Okay, let me demonstrate where it comes from. Turn in your paper over. Okay, and we're going to multiply out some binomials. So let's start with x plus y to the 0 power. X plus y to the 0 power is 1. Anything to the 0 power is 1, just so you know. Then if I have x plus y to the first, that gives me x plus y. Then I can do x plus y squared, and that gives me x plus y times x plus y, which gives me x times x is x squared. X times y is xy. Y times x is another xy. And y times y is y squared. We're all copying this down right now? We're going to combine our like terms and get x squared plus 1 is 2xy's. And that's that binomial. Now we're going to keep going. We're going to do x plus y cubed. Okay, so I'm going to take basically this, because this is x plus y. That's x plus y, sorry. Let's write it out first. Times x plus y times x plus y. Okay. So basically I take this, because that's x squared, or x plus y squared. And then we're going to multiply it by another x plus y. So we're going to do x squared times x gives me x cubed. And then x squared times y gives me x squared y. Then the 2x times x is 2x. X times x is x squared y. Then the 2xy times y gives me 2x, and then y times y is y squared. Then I'm going to take the y squared and multiply that by the x and get x y squared. Then I'm going to do the y squared times the y and get y cubed. Finally, I'm going to combine my like terms. This and this are like terms, and then this one and this one are like terms. I'm going to get x cubed plus 3x squared y, and then another 2 and a 1 gives me another 3x, but y squared this time, plus y squared, or y cubed. Any questions over that? But we can keep going and get x plus y to the 4th. No, what? And we get x plus y. Keep writing, x plus y times x plus y times x plus y. And let's multiply this all out, right? Okay, so we can multiply this again. I would just take this polynomial now and multiply it by another xy, which is super duper fun. And I've all demonstrated how fun it is by your wonderful whining as a result of me writing this out. So now we have Pascal's triangle, which can help us because we will have to expand binomials like this. Okay? So let's demonstrate our wonderful Pascal's triangle. Oopsie, let's find where I'm at. Nope, not there. Okay, let's go back here. And let's do this. So Pascal found that we can see the patterns within our binomial expansions. Okay, so if we look back at what we wrote out, let's see if I can get back there. Nope, of course not. Okay. X plus y to the 0 power just gave me the number 1. So right here goes 1. And this is row 0 because it's x plus y to the 0 power. Then if we go back, the x plus y to the first, we're going to take the coefficients here and here of our variables. So that's 1 and 1. And that goes here. And so that is row 1 because it's x plus y to the first. Okay. And if we look back, x plus y squared, my coefficients were 1, 2, and 1. So that's our row 2. So 1, 2, and 1, and that is row 2 because it's x plus y squared. Those are the coefficients when I square x plus y. One is the coefficient of the x squared, 2 is the coefficient of the middle term, and 1 is the coefficient of the y squared. The next one then is going to come from my coefficients here. 1, 3, 3, 1. 1, 3, 3, 1. And this is row 3 because it's x plus y cubed. Any questions over that? Now, we didn't do the fourth because we didn't want to do that. Okay, so now I have to come up with the way of finding the coefficients of row 4. Yeah, it's 1 and 1 here. 4. You're going to add these two together. 6. Add these two together. 4. The next one then is row 5. It's x plus y to the 5th power. Then again, the 1s are on the outside, and then you add 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And 4 plus 1 is 5. Then we go to row 6. And we get x plus y to the 6th. And then we add it all up. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And then 1 again. Keep going. Fill it all out. If you want to check yourself, you can look at the completed one to make sure your numbers are all good. Because if you get off once, it ruins the rest of it, right? Oh, good. Okay, so here's all our Pascal's triangle. It's awesome because there's tons of patterns in it. We don't have time to look at all of them, but it's nice. I'll show you one. Well, you can kind of see the pattern of just, why is this not working? There you go. Right, all the ones on the sides, and then this tells you the row 2, row 3, row 4, row 5, 6, so on all the way down, 12, 12. Okay? Also, so let's say we want to find this number here. You're just going to add up all of these numbers. 1 plus 2 plus 3 gives you 6. And this will work anywhere. So if you start here, go up diagonally in all of these numbers. 1 plus 4 plus 10 plus 20 plus 35 gives you 70. Just so you know. Yeah, it's really cool. To get to this number here, you can add up all of these numbers here in this, and you'll get 462. Yeah. Okay, so that's all that fun. Now we're going to go to the next page. Let's see. Oh, boo. So we already did these first 3 expansions on the back. Now we're do the 4, x to the 4th. For the coefficients, you're going to use the row 4 of Pascal's triangle. Okay, so that's where the coefficients are come. Now you need to worry about the variables, okay, and the exponents. So this is the 4th degree. The x starts as a degree of 4 and goes down by 1. The y starts with a degree of 0 and goes up by 1. Okay, so when I start this, I always leave a blank for the Pascal triangle. Here's a blank. So I'm going to start x to the 4th degree. Any questions over that? So another blank from my Pascal's triangle number. Now x is going to go down by 1. So 4, then 3, Okay, and y is going to go, it was 0 here, so then it's going to go up by 1. So 0, then y to the first. Then you have another blank for your Pascal's triangle number. X goes down by 1, y goes up by 1. X goes down by 1, y goes up by 1. X goes down to 0 now, so there's no x's left, and you end at y to the fourth. Any questions over that? Now you can check to make sure you've done this correctly, because the exponents should always add to 4. So this is x to the fourth, and then y has 0 exponents, so that's 4. X has 3 and y has 1 here, so that's 4. X has 2, y has 2, you add them, get 4. X has 1, y has 3, that's 4. And now y has 4 and x has 0, so that's 4. Any questions over that? Now I'm going to go back to our Pascal's triangle. Find row 4, which is right here. I want to use those numbers for my coefficients. So this is 1, 4, 6, 4, 1. Any questions over that? And that's what I would get if I expanded this, if I multiplied x plus y out 4 times. Any questions over that? We're good? Okay. Now, oftentimes they don't have just variables. Now they'll have numbers as well. So let me show you how we do that one. So we do that same thing, only we're going to start with to the 5th degree. So we have our blank for Pascal's triangle. You have x to the 5th power now. Plus a blank. X goes down by 1. Then the 2, negative 2, make sure you're bringing the negative, goes up to 1 to the 1st power. Then you use your blank. X goes down by 1. Now my second term, negative 2, goes up by 1. Then I have another blank. Then I get x goes down by 1. And 2 goes up by 1. Keep going. X goes down by 1. 2 goes up by 1. No more x's. I'm just left with the negative 2 to the 5th. Okay. Now I'm going to write in our Pascal's triangle. So we're at row 5 now. Row 5 is 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. But we're not done now. So now we have to multiply the powers of 2. So do all that powers of 2, multiplying it. So this doesn't have any powers of 2, so we're good. This doesn't have any powers of 2, just to the first, so it's just negative 2. This one we have negative 2 squared, which is 4. This is negative 2 cubed, which is negative 8. This is negative 2 to the 4th, which is 16. And this is negative 2 to the 5th, which is negative 32. Any questions over that? So we're not done yet. So now I have to multiply. So I multiply the Pascal's numbers by the powers of 2. It should be negative 2. So now I'm going to take this, so the first one doesn't change anything because that doesn't have any 2's. So that's just x to the 5th. Now I'm going to take that negative 2. I'm going to multiply it by the 5 to get negative 10. So this will be negative 10, and then x to the 4th. Okay, then we're going to take the 4 times the 10 and get plus 40, and then x cubed. Then I'm going to get the negative 8 times 10 and get negative 80, and then x squared. I'm going to get the 16 times the 5, and that 2 gives me 80, and then x. And then finally, the negative 32 times the 1 just gives me negative 32. And that's what I would get if I expanded the x minus 2 to the 5th power. Any questions over that? Why? Because you'll need to expand. This is the shortcut. Yeah. You can do that, and that's what's great, right? This is just another way to do it, okay? Now, sometimes they'll ask you to find the 4th term or the 3rd term or the 5th term in your sequence of numbers or your polynomial, okay? For me, I have to go to the 4th degree. Okay, you're going to do that 4th degree. I'm going to leave my blank. My first one will be 3x to the 4th plus my blank. I will get 3x to the 4th and then negative 2y to the 1st. Third, thank you. Go down by 1. Then plus my blank. Then we get 3x, it's squared, and then negative 2y squared, plus my blank. Then we're going to have 3x to the 1st, and then negative 2 cubed. Now, this is the 1st term, this is the 2nd term, this is the 3rd term, this is the 4th term. Since I've gotten to the 4th term, I don't need to keep going. Okay, if I wanted to write out the whole thing, okay, I could. I just care about this one right now, because it wants to have the 4th term. Okay. So I need to go back and find the 4th degree, Pascal's triangle, which is 1, 4, 6, 4. So now I have to multiply all of this out. So the 3 is the 3, because it's just to the 1st power. The negative 2 cubed is negative 8. So we're doing just what we did here. Multiply the powers of each of my numbers out. Then I need to multiply the 8 times the 3 times the 4. 4 times 3 is 12, times negative 8 is negative 96. Let's make sure it looks good. The x is to the first power, and then the y is cubed. And so that is my fourth term if I expanded 3x minus 2y to the fourth power. Any questions over that? Yes. If you can, yes. For me, it's a little bit harder to do. I like to write it out to make sure, because then I confuse myself. But if you can do it, you're just more likely to make mistakes. Any other questions? Okay, on the back of that page, we're going to do some old school notes. Old school notes. Okay, I'm going to teach you yet another way to do this. Okay, so there's a thing called binomial theorem. And it's another way to expand polynomials. It uses combinations, which we just taught you in 6.7, in order to do this. So let's start with a way to expand. Let's just start with our x plus y. Okay. Okay, to expand a binomial, you can use combinations to find those coefficients. So the variables are the same. You're going to start with the variable to the fourth degree and go down by 1 and then up by 1. Okay, but the leading coefficient you can get by using the combinations. So that first combinations, if you don't have the Pascal's triangle, since it's a degree of 4, you start with the degree of 4. That is always, it's always out of 4 choices. And your first one, you're going to choose 0 things. The x is to the fourth now. Then you're still going to have a combination of 4 items, but now you're going to choose one of them. The x now goes down by 1, so it's x cubed, and then y to the first. Then you have your combination still out of 4. You're choosing from 4 because you're fourth degree, but now you're going to choose 2, so this just goes up by 1. The 4 doesn't change. That's the degree each time. So if this is a 5th degree, this would have a 5. Okay, and then the x now is squared and the y is squared. Then you use your combination again, 4. Now you're going to choose 3. You're going to get x and y cubed. Then you get your combination of 4, choose 4. And x, oh no more x's, x to the 0 power. And then y to the fourth. Any questions over that? Then you plug all these fun combinations into your calculator. 4 choose 0 is 1. So you just get left with x to the fourth. Then 4, choose 1. There's 4 different things I can choose from, so there's 4 different ways I can choose them. Then 4, I'm choosing 2. You plug that in, and I should get what? 6 x squared y squared. 4, choose 3 is 4 x y cubed. And then 4, choose 4. There's only one way I choose them all, and so that'd be y to the 4th. So that's another way to expand my binomials. This one? 4, choose 3. Plug that into your calculator. Because you should get 4 when you plug that in. Any other questions? We're good? Okay, so now what happens if we're given a number? So like x plus 3 to the 5th power. Okay, so now we're doing the degree of 5. So you're going to have 5, choose 0. Then you're going to have x to the 5th and 3 to the 0 power. Then you're going to have a combination of 5, choose 1, x to the 4th, and now 3 to the 1st. Plus, combination, still 5, now go up by 1, which is 2, x cubed, 3 squared. Plus 5, choose 3, x squared, and then 3 cubed, plus 5, choose 4, x, 3 to the 4th, plus, I'm going to have to write down here, 5, choose 5, and then 3 to the 5th. Any questions over that? Okay, now we have to find the combinations, and we have to do all the powers of 3. So this should be x to the 5th plus 5, x4, 3, plus 10, x3, 3 squared, plus 10 again, x squared, 3 cubed, plus 5, x, 3 to the 4th, plus 1 times 3 to the 5th. Any questions over that? Okay, now I'm going to multiply out the powers of 3. Woohoo! Do you? That's fine. I would not use this method necessarily to expand a binomial. I will show you why we want you to know how to do it when we're dealing with probability, because you're going to use it for probability. but we need to learn how to do it first. Okay, so now we're going to have the 3 to the first is just 3. 3 squared is 9. 3 cubed is 27. 3 to the fourth is 81. 3 to the fifth is 243. I'm not quite done. Because now I have to multiply the 3 times the 5. Yes. So it's x to the fifth to start with. Then we're going to do 3 times 5 is 15. X to the fourth. Plus the 9 times the 10 gives me 90. X cubed. Plus the 27 times the 10 gives me 270. X squared. Plus 81 times 5 is 405. Just X. And then plus 243 times 1 is 243. Whew, so much fun. So that is my polynomial. Any questions over that? We're all good? Okay, you have the worksheet. Okay. Oh, but you get to do it for homework. Yay. So you're not going to be able to do the word problems because those are the probability ones. So just skip those for tonight. We will learn how to apply it to a probability on Wednesday. You're just going to do numbers 1 through 4 and then 15 through 21 on the back. Okay? Oh. You might want to yeah, more paper for that. Let me look in the back and see if there's anything.